Hi dear children, I welcome you once again to our Gsquare Math channel. I'm very happy that today we are going to start the usage of trigonometry. The starting of the trigonometry, the first video of the trigonometry we narrated what are the uses of trigonometry. The main uses of trigonometry is to measure the height and distance of a particular objects. When it started, the scientists they started using this to find out the distance between the two stars or something. What are the distance between this? Now today we are going to see the preliminary stages of how to measure the height and distance of two objects. Before we are going into this, let me explain some important definitions of some particular angles. So whenever a man is observing the height of the tower or height of the tree or whatever it may be, the height of the top pole, whatever it may be, and a man has to be there and he is observing an angle, some angles are formed between him and this objects. Suppose AB is a tower and the man is standing here. He is observing the top of this. This angle is formed. So what is that angle called? Some terminology we are going to define before going to see this type of problem. A man is standing on the ground level and this is his eye. The imaginary line drawn perpendicular to the eye of the observer, this imaginary line drawn perpendicular to the eyes of the observer or parallel to the ground. For the same. So this is known as the eyesight. Eyesight of the observer. Now when I am telling this eyesight of the observer, now coming to the object. Object may be anything. It may be a tower or it may be a building or it may be a flag post or it may be anything. So that object may be on the top or below of the eyesight also. Above the eyesight or below the eyesight. If suppose above the eyesight, if the object lies, the line joining the object with the observer's eye is known as angle of elevation. So this is the object. The object is above the eyesight. This is AB is the observer. B is the eye of the observer and BC is the line of sight. So the angle between the line of sight and the eyesight, if the object is above the eyesight, is known as angle of elevation. If the object is below the eyesight, this is also line of sight. Here the object is E. Observer's eye is this. The imaginary line joining the eye of the observer with the object is line of sight again. So the angle between the line of sight and the eyesight is known as angle of depression. Angle of depression if the object is below the eyesight. So two things. One is the eyesight. Eyesight is the imaginary line drawn perpendicular to the eye of the observer. And there are two objects. One is a object C, another object is E. This object is lying above the eyesight and the object E is lying below the eyesight. So this line is also line joining this B and C is a line of sight and the line joining B is also known as line of sight. The angle between the eyesight and the line of sight is defined as the angle of elevation if the object is above the eyesight. And if it is below the eyesight, that is known as the angle of depression. These two, angle of elevation and angle of depression, is always we need to find out the height and distance between the two objects. So this will be given in the problem itself. You have to read very carefully the problem. To solve the height and distance problems are very simple. The trigonometry knowledge what you have studied already, we are going to apply. So, but understanding the problem is very important. How to understand that? Read the problem. Again and again read. Try to understand what is the actual object. Where is the position of the observer? Whether the height of the observer is given or not. If it is not given, the eye of the observer is coincide with the ground level. So these are the things you have to observe, read it very carefully in between the lines and try to understand what is what. Once you understand, just draw a small picture. Let me take a small problem, then we will come back. The angle of elevation of the top of the tower is 45 degrees. Let me read the problem. The angle of elevation of the top of the tower is 45 degrees from a distance of 10 meters from the foot of the tower. The angle of elevation of the top of the tower is 45 degrees. So what is the object? The top of the tower. What is the angle of elevation? That means the man is standing on the ground. He is looking up. If he is looking up, it is the angle of elevation. If he is looking down, it is the angle of depression. So the angle of elevation at the top of the tower is 45 degrees from a distance of 10 meters from the foot of the tower. Calculate the height of the tower. Simple problem. Just to explain this one, I have taken a small problem. Let AB be the tower. So, after you have drawn the picture for the given height and distance problem, you have to narrate what is what. In the examination, you got to write it. Without writing what is what, don't start the problem. Or after drawing this, let me write. Simple narration. Let AB be the tower, let C be the position of the observer, and let the distance AC is equal to 10 meters. That's all. Not more than that. So, now we have to find out what is the height. Let H be the height of the tower. This is my assumption. You are asked to find the height of the tower. This is my assumption. Let H meter be the height of the tower. Now you see that with your previous knowledge, what is the trigonometric ratio which connect these two sides? This is a right angle triangle. This is an angle given. There is the opposite side, there is the adjacent side. What is the relation, trigonometric relations? Trigonometric ratio which connect these two sides. So which we know that from right angle triangle, ABC at A. We know that side connected this is tan 45. So tan 45 is equal to AB by AC. So this implies tan 45, we know the value is 1. So the height of the tower is 10 meters. Simple. Only thing is you have to understand the problem, draw a small picture, slightly write in a very simple sentence. What is what? That's all. Let AB be the tower whose height is H meters. And let C be the position of the man from the tower at a 10 meters. So the angle will be bigger steps. So this is the height of the tower. Now the small question, I am slightly twisting this question. Suppose if the height of the man is given, the height of the man is 1.5 meters. See the problem. A man whose height is 1.5 meters standing 10 meters away from the tower and observing the top of the tower. See the problem? Here nothing is changed. All the data are same except the height of the man is given here. So earlier what we have taken, the eye of the observer is at the point C on the ground level. Now the eye of the observer is shifted 1.5 meters above the ground level. So let CD be the height of the man. He is observing here. This angle is 45 degrees. Earlier this angle is 45, now that angle is 45 degrees. As the height of the tower man is given, this is angle 45. So from triangle BED at E. Now I am considering BD as a right angle triangle at E. So what is tan 45? This we have to find out. Height of the tower we have to find out. And this is 1.5. So this is also 1.5. So from the right angle triangle, tan 45 is equal to BE by DE. DE is nothing but AC. This nothing but this, which is given 10 meters. We know what is tan 45? Tan 45 is 1. Therefore, BE is equal to 10 meters. Don't stop this answer here itself. This is not the height of the tower. This is nothing but be a part of the tower only it is. So to get the height of the tower, you get to add AE also. AE is nothing but the height of the man. So therefore, the height of the tower is equal to BE plus AB, that is BE plus DC, the height of the man. That is 10 plus 1.5. That is 11.5 meters. So the actual height of the tower is 11.5. I am standing here. Earlier my eye is coincided with the ground level. I am observing from there. Now the height is also given. If the height is not given, doesn't matter. Think that the eye of the observer is nothing but on the foot, on the ground level itself. So let me take another problem. A man who is standing in between the two buildings of same height on either side of the road, and the angle of elevation at the top of the building is observed as 60 degree and 30 degree. If the width of the road is 10 meters, find the height of the building, also find the position of the man. So in this problem, there are two buildings on either side of the road. There is a road. On either side, the building is standing. A man is standing in between. He is observing the top, and the angle of elevation is given as 60 degree and 40 degree. Okay? Okay. So you are asked to find out the height of the building. And you got to actually find out what is this position E. From A this much, from B this much. Okay. So from right angle triangle, So you can write a small write-up about the picture that AB and CD are two buildings of height h meters. Let E be the position of the man in between the road, in between the two buildings, and the angle of elevation observed is 60 degree and 30 degree. That's all. The width of the road is given 10 meters. So let us take two right angle triangle. Let A, B, E at A. Tan 60 is equal to AB by AE. So this implies AE is equal to AB by tan 60. We know the value of tan 60 is root 3. So that is equal to AB by root 3. Therefore, AE is equal to AB by root 3. First equation. Let me repeat once again. First, I am considering the right angle triangle ABE. This distance I have to find out. This is total distance is given. So if I find out this one and if I find out this one, you can just add it, you will get 10 meters. So from that you can find out the h. That's the idea. So same thing from triangle ECD at C. Consider this right angle triangle ECD at C. Tan 30 is equal to DC by EC. So DC is equal to H. Right, tan 30. DC by EC. This implies EC is equal to DC by tan 30. We know the value of tan 30 is 1 by root 3. So this implies EC is equal to DC root 3. 1 by root 3 will go up as root 3. So this is the second equation. Now we have to make use of the given thing. What is given? AE plus EC is equal to 10 meters is given. It is given that AE plus EC is equal to 10. What is AE? AE is equal to AB by root 3 plus EC is given DC by DC root 3 is equal to 10. But remember, AB and DC are the height of this building, both the same height. Therefore, this also H, this also H. So H by root 3 plus H root 3 is equal to 10. So take H common out. 1 by root 3 plus root 3 is equal to 10. So there is H into 1 plus 3 by root 3. I am taking H and root 3. Is equal to 10. So H is equal to 10 root 3 by 4. That is equal to 5 root 3 by 2 meters. Therefore, height of the building is 5 root 3 by 2. This is the first question. Now, what we calculated is only the height of the building. Both the heights are same, therefore H is equal to this. Now, another question is also given in that, asked in that. What is that? Find the position of the man from where he is standing. So, AE is equal to this much. H is equal to this. A is equal to this. Find out what is E. There's a 10 meters in this. So we can, already we are having the two relations. First equation, second equation. From that you can find out. Or by using the triangle also you can find out. This height we know. This angle is given. Tan 60 is equal to this by this. You can find out the portion of the and hence this type of simple problem, we started with a simple problem. In the next video, we are going to take a problem with more informations. And wait for that and watch the next video also. If you like this, just subscribe and click the bell button.